You are standing at the edge of a forest. It is about 60,000 years ago. You have been walking for 3 days. Your feet hurt, you are hungry, your entire outfit is one badly positioned animal skin. The world smells like wet leaves, cold mud, and something dead nearby that you are trying very hard not to investigate. And then you see one. Not a deer, not a wolf, not one of your people. Something else. Shorter than you, wider than you, built like someone compressed a rugby player into a prehistoric fridge. The brow ridge is significant. The jaw looks like it could open walnuts without tools. The shoulders suggest this person has never once lost an argument with a tree. It is carrying something. A tool maybe? Food maybe? A bone maybe? Hopefully not from anyone you know. And then it looks at you. And your ancestor apparently thought, yeah, okay. Not once, not twice. Across tens of thousands of years, in different places, at different times, ancient humans kept meeting Neanderthals and making roughly the same decision, which is already a strange thing to learn about your family history. But we know it happened because they left evidence, not in a cave painting, not in a love letter scratched onto a mammoth rib, inside you, right now. Somewhere in your DNA, there's a tiny prehistoric footnote that says, by the way, one of your ancestors got very friendly with someone from another human species. For most people outside sub-Saharan Africa, around 1 to 2% of their DNA comes from Neanderthals. In some East Asian populations, the amount is often slightly higher.
Which means this was not just one awkward evening near a campfire. This happened often enough to leave a permanent mark. The question is not whether humans and Neanderthals mixed. They did. The question is much stranger. Why? Why did ancient humans look at another species of human, a stocky, powerful, cold-adapted, heavy-browed cousin who had been living in Ice Age Europe for hundreds of thousands of years, and think, yes, this one, this is the one? And the answer is partly biology, partly survival, partly loneliness, and partly, unfortunately, the same reason people throughout history have made terrible dating decisions. They were nearby. Before we talk about why humans and Neanderthals got together, we need to fix the image in your head. Because for more than 100 years, Neanderthals were treated like the embarrassing uncle of human evolution. You know the image. Hunched back, dragging knuckles, mouth half open, looking permanently confused by the concept of fire. Basically, a caveman who just discovered taxes. But that image is mostly wrong. A lot of it comes from early reconstructions of Neanderthal skeletons, especially one famous reconstruction from the early 1900s. The skeleton belonged to an older Neanderthal with serious arthritis and other health problems. Scientists looked at this poor ancient man, saw his damaged bones, and said, ah yes, this must be the standard model. Which is a bit like digging up a modern human with back pain, bad knees, and a slipped disc, then concluding that all humans walked like tired question marks.
Neanderthals did not drag their knuckles. They walked upright. They were strong, very strong. Their bodies were compact, muscular, and adapted for cold climates. If a modern human body is designed like a long-distance runner, a Neanderthal body was designed like a person who could wrestle winter and win. They had large brains, too. On average, their brain size was comparable to ours, and in many cases larger. Now, bigger brain does not automatically mean smarter. If that were true, whales would be doing calculus, and every large-headed baby would be running a bank. But it does mean Neanderthals were not stupid. They made tools, they used fire, they hunted huge animals at close range, which is either bravery or terrible risk assessment. They made ornaments, they used pigments, they cared for injured members of their group. We have Neanderthal skeletons with healed injuries so serious that the person could not have survived without help. Broken bones, degenerative disease, missing teeth, injuries that would have made hunting difficult or impossible. Which means somewhere in Ice Age Europe, a Neanderthal with a terrible injury was still being fed, still being protected, still being kept alive. Not because he was useful that week, because he was theirs. That is not savage behavior, that is society. There is even evidence that some Neanderthals buried their dead. In some famous cases, people have argued that flowers may have been involved, though scientists still debate that part.
And honestly, even if the flowers turn out to be complicated, the bigger point remains. Neanderthals were not monsters lurking in the dark. They were people. Different people, but people. And they had been living across Europe and parts of Western Asia for hundreds of thousands of years before modern humans arrived. Think about that. Our ancestors came out of Africa and entered landscapes that Neanderthals already knew intimately.
They knew the rivers, they knew the caves, they knew which plants killed you slowly and which ones killed you with impressive efficiency. They knew where the animals migrated, they knew where the wolves hunted, they knew which valley looked beautiful in spring but became a freezing death funnel in winter. Modern humans were the newcomers. Neanderthals were the locals. Imagine moving into a city where someone else's family has lived for 300,000 years. They know every shortcut, every water source, every dangerous neighborhood, and exactly which mushroom makes you see your ancestors. That is the world our ancestors entered. And apparently, some of them took one look at the locals and thought, this could be useful. Also, not bad. So when did this actually happen? The main period of mixing between modern humans and Neanderthals seems to have happened roughly 50,000 to 60,000 years ago, around the time modern humans were moving out of Africa and into the Middle East, Europe, and Asia. But it was not just one event. It was not one confused couple behind a boulder accidentally changing the future of human genetics. It happened multiple times.
In different groups, across long periods, which means humans and Neanderthals were not just briefly aware of each other, they were sharing landscapes, crossing paths, competing, avoiding, watching, maybe trading, maybe fighting, maybe flirting very badly across a language barrier. And honestly, flirting across a language barrier is already difficult. Now imagine both of you are holding spears. Neanderthals lived in small groups. Modern humans did too. These groups would have met near rivers, caves, hunting grounds, coastlines, migration routes, all the places where hungry people naturally end up. Because no matter what species of human you are, everyone eventually gathers around water, food, and somewhere that is not actively trying to freeze you to death. What did the first meeting look like? We do not know. There was no documentary crew. No one carved Day 43, met strange thick man, great shoulders, unclear intentions. But we can imagine the tension. A group of modern humans enters a valley, they see smoke. Smoke means fire. Fire means people. People means danger, or food, or both. Across the clearing, a Neanderthal group sees them too. Everyone freezes. The children are pulled back, the adults grip their tools. No one knows what happens next. This is not like meeting a stranger from another village. This is meeting another kind of human. Close enough to be familiar, different enough to be unsettling. Their faces are different, their bodies are different, their voices may have sounded different.
They may have smelled different too, which is not a small thing when everyone involved lives outdoors and soap has not been invented yet. Maybe the first encounters were tense, maybe some were violent, maybe some ended with people backing away slowly while pretending they meant to go in that direction anyway. But some encounters did not end that way. Some ended with exchange. Maybe tools, maybe food, maybe information, maybe someone pointing toward a herd of animals and everyone understanding the universal ancient language of big meat that way. And over time, in some places, people got closer, close enough for children to be born. That is the part genetic evidence makes hard to deny. Modern humans and Neanderthals had children together, and some of those children survived. Were these relationships romantic? Sometimes, maybe. Were they practical? Probably. Were they forced? Possibly, in some cases. We should not turn prehistory into a cute cartoon romance. Ancient life was hard, and human behavior has never been purely wholesome, but the pattern does not look like one single incident. It looks like repeated contact, repeated mixing, repeated chances for two very similar, very different humans to look at each other and make a decision that would still be sitting in our DNA 60,000 years later, which is a long time for one questionable campfire choice to stay relevant. Here is where the story stops being merely strange and becomes genuinely remarkable. The Neanderthal DNA that survived in us is not random.
Over tens of thousands of years, natural selection removed a lot of it. Some Neanderthal genes were probably harmful in a modern human body. Some simply did not help. Some may have caused problems when mixed with Homo sapiens genetics, so over time, much of that DNA disappeared. But some parts stayed, and the parts that stayed tend to show up in very interesting places. Immune system genes, skin and hair genes, fat metabolism genes, genes related to how the body responds to cold, sunlight, and pathogens. Which makes sense, because Neanderthals were not just random strangers. They were humans who had already adapted to environments our ancestors were entering for the first time. Cold European winters, different diseases, different diets, different sunlight, different animals, different everything. Modern humans were walking into Neanderthal territory like, wow, this is beautiful. And the environment replied, thank you, you will die by Thursday. Neanderthals had been surviving there for hundreds of thousands of years. They had the biological toolkit. Their bodies were built for cold. Their immune systems had dealt with local pathogens. Their skin and hair traits were shaped by Eurasian climates. Their metabolism was adapted to harsh conditions, where food could be seasonal, fatty, and occasionally trying to gore you. So when modern humans interbred with Neanderthals, they did not just get a weird family story. They got genetic equipment. Not always good equipment, not always compatible equipment, but sometimes extremely useful equipment.
Think of it like downloading a survival patch, a slightly hairy, heavy-browed Ice Age survival patch. Some Neanderthal immune variants may have helped modern humans fight infections in new environments. Some skin and hair variants may have helped with climate adaptation. Some metabolism-related genes may have helped in colder regions where diet and fat processing mattered more. This does not mean your immune system is secretly a caveman with a club, although honestly, sometimes it behaves like one. It means that part of your biology was shaped by another human population that had already solved problems your ancestors were just beginning to face. In a harsh environment, that matters a lot. Because evolution does not care whether a gene came from your species, your cousin species, or one extremely awkward encounter near a glacier. Evolution only asks one question: does it work? If it helps you survive long enough to have children, it stays. If it does not, it gets quietly removed from the guest list. And some Neanderthal genes worked. That is the incredible part. Your ancestors did not just meet Neanderthals, they inherited from them. And the humans who carried useful Neanderthal variants may have had better chances in certain environments than those who did not. Which means we are not just descended from people who saw a Neanderthal and thought, yeah, okay, we are descended from the ones where it worked out. But there is a darker part of this story. Because we carry Neanderthal DNA, Neanderthals do not carry ours, because they are gone.
By around 40,000 years ago, Neanderthals had disappeared as a distinct population. They had survived ice ages, they had hunted enormous animals, they had cared for their injured, they had raised children, they had buried their dead. They had lived in Europe and Western Asia for hundreds of thousands of years. And then, not long after modern humans arrived in large numbers, they were gone. That timing is hard to ignore. Did humans kill all the Neanderthals? Probably not in the simple movie version. This was not one giant prehistoric war where Homo sapiens showed up, pointed dramatically, and said, "Remove the brow ridges." The real story was probably slower, messier, and in some ways more tragic. Modern humans may have had larger social networks, better long-distance trade, more flexible tools, more efficient ways to share information, possibly higher population growth, possibly wider alliances. If one modern human group found a better hunting route, that knowledge could spread. If one group developed a useful tool, others might copy it. If one band suffered, another might help. That kind of network is powerful, especially in a dangerous world. Neanderthal groups, meanwhile, seem to have been smaller and more isolated. Small populations are fragile. A bad winter hurts more, a disease hurts more, a failed hunt hurts more. Losing a few children hurts more. And if your group is isolated, there may be no one nearby to replace the people you lose. Over thousands of years, modern humans may simply have outcompeted them, not with one dramatic blow, but with pressure. More people. More connections, more children, more movement, more claims on the same hunting grounds. And then there is the interbreeding. Because if Neanderthals had children with modern humans, and those children were raised in modern human groups, the Neanderthal ancestry did not remain separate. It flowed into us. The Neanderthal part of the family tree did not continue as its own forest. It became branches inside ours. That is why the story is so uncomfortable. We did not simply replace them. We absorbed them. And after absorbing part of them, we moved on. The Neanderthals disappeared as a people, but pieces of them remained in the people who came after, which is either beautiful or horrifying depending on how long you think about it. And please do not think about it too long while eating. This is the part of the story that resists a clean moral. It was not romance, it was not conquest, it was not peaceful coexistence, it was not simple extinction. It was probably all of those things, scattered across thousands of years and thousands of encounters. Some meetings may have been friendly, some may have been violent, some may have involved trade, some may have involved desire, some may have involved desperation, and some may have involved two people from two human worlds looking at each other and realizing that despite everything different between them, they were not different enough. Then slowly, one world vanished into the other. And just when the story seems strange enough, it gets worse.
because Neanderthals were not the only other humans our ancestors met.
There were also Denisovans. For a long time, Denisovans were one of the weirdest mysteries in human evolution. We knew they existed mostly from scraps, a finger bone, a few teeth, bits of DNA, which is not much to build a person from. Imagine your entire dating profile being reconstructed from one tooth and some genetic fragments. That was basically Denisovan science for years. But the DNA was clear. Denisovans were real. They were related to Neanderthals, they lived somewhere across Asia, and just like Neanderthals, they mixed with modern humans. Their genetic legacy is especially strong in parts of Oceania, including Papua New Guinea and indigenous Australian populations, where some people carry several percent Denisovan ancestry. That is not maybe someone's great-great-great cave cousin. That is a major prehistoric contribution. And one of the most famous Denisovan gifts is found in Tibetans, a gene variant linked to high-altitude survival. The gene is called EPAS1, which sounds less like a dramatic ancient inheritance and more like a printer model. But it matters a lot. At high altitudes, oxygen levels are low. For most people, living there permanently is extremely difficult. The body struggles, blood thickens, pregnancy becomes more dangerous, long-term survival becomes harder. But Tibetans have a version of EPAS1 that helps the body handle low oxygen more efficiently, and that version appears to have come from Denisovans. Think about what that means. At some point, tens of thousands of years ago, modern humans mixed with Denisovans.
One of the genetic results of that mixing survived. That gene spread. And today, millions of people can live on the roof of the world partly because of a meeting between two ancient human populations. One encounter, one lineage, one inherited advantage. A prehistoric decision echoing across mountains. That is insane. That is not just history. That is biology with a very long memory. Which means the old picture, modern humans on one side, Neanderthals on the other, is too simple. The real Ice Age world was crowded. There were different kinds of humans. Modern humans, Neanderthals, Denisovans, maybe other groups we still barely understand. And they were not sealed off from each other. They met, they competed, they learned, they avoided, they fought, they had children. And then, over time, almost all of those other human groups disappeared. Except they did not disappear completely, because some of them are still here, in us. Your ancestor saw a Neanderthal and thought, yeah, okay. Someone else's ancestor saw a Denisovan and apparently thought, also yes. And now here we are, pretending modern dating is complicated. So, why did ancient humans have children with Neanderthals? Probably for the same messy reasons humans do anything. Proximity, curiosity, survival, desire, loneliness, bad weather, good shoulders, the particular appeal of someone who knows where the water is and does not flinch when the wolves howl. But the biological answer is simpler, because sometimes it worked. Not always, not perfectly, not without cost. But often enough that 60,000 years later, the evidence is still sitting in our cells, in immune genes, in skin and hair traits, in metabolism, in adaptations to places our ancestors had never known before. Every time a human body carries some ancient variant that helped its ancestors survive a cold landscape, a new pathogen, or a brutal environment, part of that story continues. The Neanderthals did not make it as a separate people. That part is sad, and we probably played a role in it. Not necessarily as villains with spears, but as competitors, neighbors, mates, rivals, and survivors. We arrived, we spread, we mixed, we absorbed, and then they were gone. But not entirely. That is the strange final twist. The Neanderthals vanished, but some part of them crossed the line into us. Their world ended, but their DNA kept walking. In our ancestors, in their children, in us. Which is either the most hopeful thing in the story or the most complicated. Probably both. Because somewhere, 60,000 years ago, two groups saw each other across a forest clearing. One human, one Neanderthal. Both hungry, both suspicious, both living in a world that wanted them dead. And at some point, somebody stopped seeing a monster. Somebody stopped seeing a stranger. Somebody blinked first. And because of that, you are here.